Hello friends, how are you? I hope you all are well. I am also very fine. आज का वीडियो रूट मीन स्क्वायर वैल्यू ऑफ अल्टरनेटिंग करंट और हम लोग उसको करंट का वर्चुअल वैल्यू भी बोल सकते. सो द टॉपिक इज root mean square value of AC alternating current or virtual value of AC, or I have mentioned here effective value of AC. तो मैटर क्या है ना, वो जो अल्टरनेटिंग करंट है ना, वो बड़ा बदमाश करंट है. हर वक्त पर उसका मैग्नीट्यूड, उसका डायरेक्शन भी चेंज होते हैं. So we say it is alternating current because it changes its direction as well as magnitude, that is also periodically. So to find the root mean square value of alternating current, हमको डायरेक्ट करंट का हेल्प लेना चाहिए. That means I would like to explain the root mean square of AC with the help of a DC. At first, I would like to write the definition of a root mean square value of alternating current. What is that current? See here. Root mean square value of alternating current is defined as the value of steady current, means direct current. Value of steady current which produces same heating effect. Same heating effect in a certain resistance. In a certain resistance in a certain time as it produced by an AC in the same resistance, in a same resistance in same time. That meaning is that I have written root mean square value of alternating current is defined as the value of steady current, means value of direct current, which produces same heating effect in a certain resistance in a certain time as it produced by an AC in a same resistance in same time. उसका मतलब वही है कि how much heating effect produced in a resistor in a fixed time by an AC, if same amount of heating effect is produced by a DC in the same resistor in the same time, then the value of that DC or the steady current is called root mean square value of alternating current. It is also called virtual value. See here, it is also called virtual value. Let us see its mathematical derivation. What is this? R.M.S. Root mean square value of alternating current. So I am rubbing it. Let us see. Here, root mean square value or virtual value. You know that when current flows through a conductor, through a resistor convert that electrical energy into heat energy. Now let us here. This is the graphical representation of the alternating current. See here. Suppose for completing one cycle, the time is taken t. The time period is t second. Okay. Let the time period bt, that means you know already this is 2 pi by omega. Let the time period be divided into n small divisions. Okay. N small divisions of equal interval of time. That means each interval how much? Each interval will be equal to t by n. See here. Here the total time is t second. I am dividing the t into a number of small parts. Okay? All are equal parts, no doubt at all. So each part will be equal to t by n. Okay? Let I1, I2, In be the current. Let I1, I2, I3 up to In be the instantaneous current, be the alternating current in the small interval of time. Okay? Now let H1, H2, H3, Hn be the heat produced during this small interval of time. So I1, I2, I3 is the current, whereas the H1, H2, Hn the heat produced during that small interval of time due to flow of current. Okay, so now we have studied in our 10th class level, high school level में हम लोग स्टडी किया heat is directly proportional to square of the current. Heat is directly proportional to time. We have studied the equation heat is equal to I square RT. We have studied. So if it is heat equal to I square RT, so I can write that here H1 is equal to I1 square RT. Similarly, H2 is equal to I2 square RT, or like that Hn is equal to In square RT. So in this case, in place of small t, I am using T by N. Everywhere I am using T by N. Here also it is T by N. Because that small time I have taken the total time into, I have divided into N divisions. So each time that is T by N. So I mention like that. So the heat produced in one cycle, heat produced in one cycle means here to here, complete cycle, one positive half, one negative half. Heat produced in one cycle H is equal to, I can write H1 plus H2 plus Hn, or I can write this is I1 square R T upon N plus I2 square R T upon N, like that, plus In square R T upon N. Okay, so I hope you are understanding it. Very simple things. The complete heat, the total heat produced during its traveling from here to here means in one cycle, जितना हीट पैदा हुआ एक साइकिल का अंदर वो टोटल हीट मैंने यहाँ पर लिखा H equal to H1 plus H2, or I can write that this is equal to I1 square plus I2 square up to In square in within bracket R T upon N. Clear? Let IV is equal to virtual value of AC. Let IV be the virtual value of AC. Then I can say that this H equal to IV square RT. If the total time is T, resistance is R. Here the current is flowing in the same resistance. Suppose the resistance is capital R. That is both cases. It may be for DC, it may be for AC. I have written the same resistance, certain resistance. So here I have taken the resistance I square RT. This is equal to total heat. What we got? We got it I1 square plus I2 square plus In square RT upon N. So here RT cancel. Then how much left? This is I1 square plus I2 square up to In square divided by N. So this is IV square virtual value, or you can say R.M.S square. So implies that this IV, I am taking square root in both sides, is equal to I1 square plus I2 square plus up to In square divided by N. This is about the root mean square value of alternating current. This I written V for virtual value. You can use it as root mean square value. यहाँ पर मैंने लिखा, क्या उसको भी वर्चुअल वैल्यू बोलते हैं. So what is root mean square value? That is only virtual value. So I can say that. So I am drawing this one. So I can say that root mean square value of AC is equal to square root of mean of square of the instantaneous current. So this is about root mean square value of alternating current. Next concept what I am going to explain be an important concept, that is relation between virtual value and peak value. Relation between virtual value and peak value. Children, don't forget to share this video. As a result, your friends also can get the benefit. Don't forget to comment. See here, relation between virtual value and peak value. Relation between virtual value and peak value. Okay? Virtual value means IV or R.M.S. Peak value, this is I0. Already in my last video I have explained about the instantaneous current. I explained about the peak value, whether it is your current, it may be EMF, it may be voltage. Okay, let us see. So relationship between virtual value and peak value. Okay, let us see. Let dH be the heat produced in the time interval dt in a resistor of resistance R. What I have written? DHB, the heat produced, small amount of heat produced in the small time interval dt in a resistor of resistance R. So already I said that heat formula, heat is equal to I square RT. I said heat is equal to I square RT. So now I can write that this DH, this is equal to I square RT. So DH is equal to I square R dt. I square RT. Here time I have taken dt, resistance I have taken R. Or I can write that this is equal to I naught sine omega t square R into dt. This is the instantaneous current. I naught is the peak value. I want to show the relationship between R.M.S and I naught, or IV and I naught. So the heat produced, that is the product of I square R and dt. I mentioned I naught sine omega t square R into dt. Suppose the total, we have to calculate the total heat produced in cycle, in time t. Okay. So now I can write that. So total heat produced, that is equal to I naught sine square omega t, I naught R I am writing here, into dt from 0 to t. Complete cycle, how much heat produced during the traveling of current in a complete cycle. I have written that is I naught sine square omega t dt. So I can write this is equal to 0 to t I naught R. So I should write here, this is the constant. So I naught R sine square omega t into dt. I have to take the integration. Okay. So before taking this integration, so see here, cos 2a is equal to 1 minus 2 sine square a. That means 2 sine square a is equal to 1 minus cos 2a. Or I can say that sine square a is equal to 1 minus cos 2a divided by 2. I am using same thing here. Okay. In place of a sine square omega t. Okay. So in the next step I am writing, see here, I naught R 0 to t, in place of sine square omega t, sine square a, that is 1 minus cos 2 omega t divided by 2. See here. So now I can write that this is equal to I naught R here 0 to t 1. So here I have forgotten to write dt. So I can write here dt, this 2 I am taking here common. So this is dt 1 minus cos 2 t. So I can write here minus, so in place of cos 2 omega t, I can write this is, so that I can write like this, directly I am writing 1 into dt minus sine omega t divided by 2 omega 0 to t. So in place of cos 2 omega t, the integration is 1 by 2 omega into sine omega t. So now I can write that this is sine 2 omega t. So now I can write that I naught r divided by 2, in place of dt I can write this is the t, okay, minus, or we can write, okay, next step I should write it, otherwise I can write it is t, and putting this value t minus sine 2 omega t divided by 2 omega minus 0 minus sine 2 omega t. That means see here sine 2 omega t. Omega t is equal to 2 pi. So this will be equal to sine 4 pi. Okay. So which is equal to 0. So I can write this is 0. So in this case I can take that sine 2 omega t divided by 2 omega. So here is, this one will become 0. So this one will become I naught. A mistake I have committed. Here I naught sine omega t square. So here is square, here is square, here is square, here is also square. So it is better I shall write here so this is equal to I naught square r divided by 2 t minus 0, here 0 minus 0. So this is equal to I naught square r by 2 into t. We got the total heat produced, but before that we know that, what we know? We know that from the previous equation, what is that? Heat is equal to IV square RT. So I can say that, so IV square RT is equal to I naught square R by 2 into T. Here RT cancel. Then what is left? Left IV square is equal to I naught square by 2, implies that this IV is equal to square root of I naught square by 2, or I can say that IV is equal to I naught by root 2. This is the relationship between virtual value and peak value, or I.R.M.S. and I peak value. Okay, so I can say that I.R.M.S. is 1 by root 2 times of peak value. I can say that virtual value is 1 by root 2 times of peak value. These things you can write like this also. Suppose this is the electromotive force. So E virtual equal to E naught upon root 2. So if I wish to compare, then I can say that this E naught means maximum EMF greater than E.R.M.S. This is greater than E main. So this is about the relationship between virtual value and peak value. In my next video, I shall explain about the different elements associated with the alternating current. Until then, bye.